Alright, so I think I'm recording. We are looking at skill packet 5, which is exponential functions and log functions. And on these problems on this skill 5G, we're looking at solving exponential and log equations. So you definitely need to know your properties of logarithms to do these, and the definition of a logarithm, be able to convert back and forth from the log form of an equation to an exponential form of an equation, which is exactly what I'm going to do right now on this one. I could rewrite this as log base 5 of 25 because 5 squared is 25, but I think it's probably just easiest to recognize and see that the base is 5, that a logarithm equals an exponent, so this base has an exponent of 2, and then this argument x squared minus 6x minus 12, or minus 2, I mean. So here's a quadratic equation. To solve this quadratic equation, I need to get it in standard form and decide whether I can factor it or whether I have to use the quadratic formula. I could even choose to complete the square. If I subtract 25 from both sides, I get negative 27 there, I believe. So I think this does factor to x minus 9 and x plus 3. So this gives me possible solutions of 9 and negative 3. But I have to be careful. I have to make sure that when you plug in 9 into here and when you plug in negative 3 into here, that you get a positive value. So 9 squared is 80. Yeah, let's do it on the calculator because I'm afraid that I'll make some silly arithmetic error. I've got 9 squared minus 6 times 9 minus 2. I got 25. Okay, so that's fine. That one checks. Or as far as, I mean, that one's not extraneous. And yeah, if you look, 5 squared is 25, so it does check. What about this negative 3? If I square negative 3, I get 9. If I, with a double negative there, it'll be plus 6 times 3, 18. And then minus 2. And yeah, I get 25. So both of these are okay. I'm not afraid of negative numbers. What I'm afraid of is when you plug it in, if you take the log of a negative number. But that time, both of them, we're taking the log of 25, which is exactly what we wanted. So hey, those are the solutions to this equation. Let's go on to the next one. So on the left-hand side, I just have a single term. It has a variable of interest, x. And on the right-hand side, just a single term. I have on the left-hand side, I notice that this term has two factors, and the factor of interest is this e to the x plus 1 because it has my variable. I need to get that factor by itself. I need to divide both sides of this equation by 5. So now I've got this factor that has my variable by itself, and I have this e to the x plus 1 is negative 1/5. Now, how can that be? If I have e to the x, the domain is all real numbers, but the range is 0 to infinity. How could I ever have an exponent that makes my answer negative? This is no solution. Alright, so I hope that helps, and I'll double check my answer key that hopefully I did have that because I'm positive that this is no solution. Alright, let's take a look at this guy. So on the left hand side I have this single term, and on the right hand side 3, but boy, on the left hand side that term is a ratio, and my true interest is in this term in the denominator that has my variable x. I'm going to make 3 a fraction so that I have a proportion. One technique to solve proportions is to cross multiply. So if I multiply along this diagonal, I just have 5 times 1, which is 5. If I multiply along this diagonal, I have 3 times that binomial. So now I have an equation that's not a fraction, so it is less complicated. And on the right-hand side, I have 2 factors. Well, the factor of interest that has my variable is this 1 plus e to the x. So I need to divide both sides of this equation by 3. 3 divided by 3 is 1. And I have a tendency that I like to write this on the left-hand side. And then that equals 5 over 3. Well, on the left-hand side, I have two terms. The term of interest that has my variable is this. So I need to subtract 1 from each side. And when I subtract 1, since this is a fraction, I'm going to write 1 as 3 over 3. So now it's easy for me to do that subtraction because I have a common denominator. And 5 minus 3 is 2. So I've gone as far as I can with trying to get this term that has my variable by itself. I need to use my properties of logarithms now, especially the power rule. Since this base is e, I'm going to take log base e of each side. Well, log base e is a natural logarithm. And then I'm going to take the natural logarithm over here. Okay. If you remember those first four problems that natural log and this e to the e are inverses of each other, and this is a base of e, so my answer is going to be x. But even I sometimes don't see that, and I'll use the product rule. I'll see this x, and I'll say, hey, I need to bring that down as a coefficient, and then I definitely am able to recognize that anytime you have a log and this base and this value are the same, this is just the number 1. E to the first power is e. This logarithm, this natural logarithm, is an exponent, and the base is e. Well, e to the first power is equal to e. So I'm done. I have my answer. X is equal to the natural log of 2/3. Since that number is smaller than 1, my answer is going to be negative. Let's jump on a calculator and get a decimal approximation. If I take the natural log of 2/3, I've got the calculator fixed to round to 3 decimals. So there's my approximate answer, but natural log of 2/3 is my exact answer. Alright, I'm going to go ahead and do the next one on this video as well. So I've got 18. Well, the first thing I notice is I've got one term on the left-hand side, two terms on the right-hand side. All of these terms are natural logarithms. They all have the same base e. I need the terms of interest are the ones that have my variable x. I want those terms on the same side of the equation, and the terms that don't have my variable on the other side of the equation. I'm going to keep this natural log of this binomial, 4 plus x, right where it is. But I'm going to subtract the natural log of x from each side so that I have these terms that contain my x on the same side of my equation. Now, I have a property of logarithms that's the quotient rule. It says if you have a difference of logs, you can condense that to a single logarithm. And it'll be the 4 plus x will be in the numerator, and this x will be in the denominator. So I have a single fraction. The natural log of this ratio is equal to the natural log of 4. Now these logs and even the natural log, they are one-to-one functions. So if the base is the same and the numbers are the same, these arguments have to be the same. This 4 plus x over x has to equal 4. I'm going to go ahead and write 4 as a ratio because I have a proportion here that if I cross multiply, that's one technique that students like to solve proportions, is to cross multiply. So along one diagonal here, along this orange diagonal, I have 4 times x. And along the other diagonal, 1 times, well, anytime you multiply by 1, you get the identical thing back. That's why they often refer to it as the multiplicative identity. So I have 4 plus x. So again, the variable of interest is x, and this term both have an x, but they're on opposite sides of an equation. I need to get it on the same side of the equation. I need to subtract 1x from each side. Well, now on the left-hand side, I have a single term that has two factors, and the factor of interest is this x. I need to get it by itself by dividing both sides by 3. And unfortunately, it's a common error that I see that people tell me that the answer is 3/4. They're like, well, I got the x by itself. I divided both sides by 4. Well, you didn't get x by itself. You got 3/4 of x is equal to 1. Be careful. You have to divide by the coefficient in front of x. I mean, the weaker students do that more often, but occasionally, if it's a stronger student like you guys in these dual credit classes, it's usually because you're tired or distracted. I mean, I know that you know to divide both sides by the coefficient. Now, when I plug in 4/3, I'm not taking the log of a negative number or 0, so if I haven't done any silly mistakes here, this is not an extraneous solution. It should check. And I guess we can plug in the calculator real quick just to make sure. On the left-hand side, what do we get? Well, if we have the natural log of 4 plus this improper fraction 4/3, what do we get? Well, out of 3 decimals, we get 1.674. On the right-hand side, if we take the natural log of 4, close that parenthesis, and then take the natural log of 4/3, we'll get the same value. Okay, so the left-hand side does equal the right-hand side when x is 4/3. So hey, I'm pretty sure that's the right answer. How many more should I do? Just finish this out in the same video? Yeah, I'm going to just go ahead and do this last problem on here. All right, so let's take a look at it. Well, on the left-hand side, I have a single term, but boy, that term is a ratio, and what I eventually want to get by itself is this e to the negative x, so I have a lot of work to get there. What I'm going to do first is make this 3 a fraction and make this a proportion. It's an equation that claims that one ratio is equal to another. So one technique that you guys like to solve proportions is to cross multiply. I'm going to multiply along that diagonal, and then I'm going to multiply along this diagonal. Now, I have to put parentheses around that denominator, because when I multiply that by 3, everything gets multiplied by 3, both terms, not just my favorite term in that binomial. So 20 times 1 is 20, and like I say, we have to distribute this 3 to both of those terms, or divide both sides, but eventually we need to get that by itself. I'm going to avoid the fractions. If 20 were divisible by 3, I'd probably divide both sides by 3 right now, right off the bat, but I'm going to distribute. So now on the right-hand side, I have 2 terms, and the term that has my variable is this guy, and so I need to get that by itself. So I need to subtract 12 from both sides of this equation. So let's shrink this up to give me a little bit of room. So this term of interest is this 15e to the negative x, and if I subtract 12 from each side, I've got 8. Well, this term on the left-hand side has 2 factors, and it's this factor, this e to the negative x, that I'm interested in because it has my variable. To get rid of the other factor, I need to divide both sides of this equation by 15. And unfortunately, I'm just going to have a fraction. I just leave this as 8 over 15. I can't even reduce it. But on the left-hand side, 15 divided by 15 is 1. So I have e to the raised to the negative x is equal to 8 over 15. And I've gone as far as I can go with properties of equality to get this by itself. I now need to take the natural log of each side and use properties of logarithms, specifically the power rule, to bring this exponent down as a multiplier. So I'm going to continue my work up here. So if I take the natural log of the left-hand side, I have to take the natural log of the right-hand side. Now, it's not written, but remember that this base is e. So whenever I have these bases, I know this left-hand side is going to be negative x there, but not everyone sees that. But hopefully everyone has studied the properties well enough to know, well, if I use the power rule, that negative x, that's an exponent, comes down as multiplication times the natural log of e. And by now, the natural log of e, it should be obvious that that's 1, because this is base e. A logarithm is an exponent. What exponent do you raise? E to what power is equal to e? E to the first power. So I have the opposite of x is equal to the natural log of 8 over 15. So that means that x is the opposite of the natural log of 8 over 15. And let me show you a trick that they will sometimes ask you. If it was a multiple choice, you might not see that as an answer. What you might see as an answer is the natural log of 15 over 8. And you're like, why do they flip that fraction? Well, because that negative sign, let's write that as a negative 1. Let's use the power rule. Bring that negative 1 up as an exponent. Now remember, negative exponents don't make my answer negative. It changes the location of the base. With this negative exponent, all I have to do to make it a positive exponent is to flip that fraction. So I have the natural log of 15 divided by 8. So I can go to a calculator and get that decimal approximation. Now, let me go back and prove to you that it's the same, that I can flip that fraction. Remember that I originally said, hey, my answer is the opposite of the natural log of 8 divided by 15. To 3 decimal places, that approximation is 0.629. I claim that the natural log of 15 divided by 8 is the same value, 0.629. So this is my approximation to this solution to 3 decimals, but my exact answer for x is the natural log of 15 over 8, or if you prefer the opposite, negative times the natural log of 8 over 15. All right, so I hope that helps. That's the end of this assignment. I think Mr. Eppert made solutions to the skill packet review. I'll double check that those are the same questions, that I haven't added any or changed any from when he made that, or that there's no typos, or just if there's any differences, why I'll take a look at it this weekend and try and figure it out. If you have any other requests, videos that you want me to make, or another different style of explanation on something, go ahead and email me, and I can try and do it. Now I can't make videos from home, and I can from school, and I do plan on this weekend on Saturday being in here kind of in the morning hours and then leaving in the early afternoon. So talk to you later, and I hope this helps.